All right, so those of you with a laptop, please go ahead and log in. Those who don't have one or don't have a set of credentials, if you can buddy up with somebody who does. So we will start. Basically, my plan is kind of to do a very slow demonstration. We'll take a basic clinical vignette. We'll go through it and hopefully show you as many pieces of the product as we can do in the time allotted. So when you log in, the first screen you see is create a study. So just go ahead and create one, name it whatever you like. I think only the name, the field in the upper left is required. Call it bootcamp, call it demo, something along those lines. And then click the button save at the bottom to land you on the page that you're seeing projected right now.
So now it says my studies. So
Let me actually go ahead and do it in sync with everybody else. So we'll log in. The first screen is my studies. If you don't have any, create new study. Once you click on this button, give it some name. And then at the bottom of the page, click Save. Then every time you log in, you will see a list of the studies you've created. The idea of the study, think of it as a folder. If you're working on multiple unrelated projects, you can create a study for each one to keep your queries about these projects separate. You can also share a study with your colleagues here at Stony Brook. So if you envision working collaboratively with somebody on a study, you might want to create this study and keep your queries in it in order to be able to collaborate. So once you create one, the tool lands you in this screen. We call it the query builder. It's here on the left side navigation bar. So you will see the name of your study at the top of the tab. The study by default is, the query by default is unnamed. You can name individual queries if you want to. The network is this notion of a scope of your query. So everybody by default should have Stony Brook University selected as your network. And if you're there, we can go ahead. So if you're there, look up, just so that I know everybody is pretty much in the same place. All right. So we'll start looking for patients with diabetes, let's say. So notice that we have two columns. One is labeled must have, one is labeled cannot have. They're not quite the same as inclusion and exclusion, but for the purposes of a demo, it's close enough. So must have are things that you want to be in patients' charts. So we're looking for diabetics. I feel like a singer with this microphone right in my mouth. So type a few letters of the word diabetes. You don't have to type the whole thing. You will notice that as you type, a little panel drops down right below this field where we bring back everything that matches the string that you're typing. You will notice that it's preceded by an icon. This orangish looking thing that says DX will tell you that there's a diagnosis. You can actually click at the top if you want to focus it on other types of information. So in this case, nothing really starts with DIABE but diagnosis. If you click on anything that drops down here, like so, you will add it to your list of criteria. So we'll pause here for a second. I'll explain what you're looking at. The code, E08 through E13, this is the range of ICD-10 codes that we've just chosen. It happens not to be a single diagnosis, it's a chapter, it's a whole range of diagnoses. The number to the right, 46,960, is the number of patients in this data set who have that fact. So if all you want to know is how many patients have a range of diagnosis from E08 to E13, you're done. It's approximately 47,000. Obviously, the beauty of the tool is to add a whole bunch of criteria and see how they intersect with one another. So let's look for medication called glucophage. GLUCOPH, let's say. So you remember I mentioned that we store medications here as ingredients. And so if I pretend that I forgot the ingredient of metformin, I can type in a brand name. We have them loaded as synonyms, and it will sort of gently guide you to metformin. Everybody able to find this? So go ahead and click on it. We can add it to our list. We will next look for, let's say, a whole class of medications. So let's type insulin. Again, a few letters should be enough. And the first line in what comes up, it has an M. Again, this is a medication you're looking at. The label is insulin. We'll go ahead, and it has this long code to the left of it that begins with the letter N. We'll go ahead and click on that, and we'll add it to our list. So let's stop here for just one moment. I will explain one more icon that you probably have seen by now. So as you hover over these terms, you will see on the right side, instead of the number, you'll see a little network icon and a little X. So the X obviously is to get rid of it. So if you click on the X, it will get erased. The little network-looking icon is interesting. So you go ahead and click on it for insulin. It will take you to a hierarchy of medications. It will make the insulin to be the one in focus, and it allows you to see where each term lives in its own hierarchy. So you start working with this tool by doing kind of a Google-like search. You type and find things. But if you ever want to switch to browse, you can click this little network icon. You can actually start with it if you wanted to. You see it's also present in the text input fields at the top. But it's easier to find it first and then click on it. So you see that insulin is a child of blood glucose regulation agents. You click on a little triangle, you open it up, and you can see individual drugs that comprise that class. So here you can actually say, for my query, I want only these two specific ones. You can use the checkboxes to add more than one to your query when you're looking at this view, and then add the Add to Query button. Or if you click the checkbox on the class itself, it'll obviously include all the children automatically. So this feature, this ability to browse, is available for any term in this interface. Obviously, don't need to. Everybody is keeping up so far? Let's go look for a lab. So we're looking for hemoglobin A1C. You can type a part of the phrase, so I'm going to type A1C. And you will see that a lab, the little L icon clues you in. Hemoglobin A1C, mass per volume in blood, that's the one we want. We're going to click on it. The behavior is going to be slightly different. Because a lab is associated with values, we're actually going to show you the distribution of values for hemoglobin A1C across the entire population at Stony Brook. So you see it has this beautiful kind of biological looking shape, almost a normal distribution, but not quite. Peaks around 5.5, has a pronounced right tail. Again, these are folks with diabetes, most likely. So you can, if you're coming in without knowing how hemoglobin A1C is measured, you don't have to memorize numbers. You can just look at it and say, well, if I cut it off at approximately here, let's say, and go to the right, I'm going to get the folks who have trouble metabolizing glucose. So that's exactly, please.
So that's all patients that have medical record numbers in Cerner, or not encountered at all medical records of each individual patient living or dead, or?
Yes, right. So the question was, define the population. Who are these 770,000 people? The answer is everybody who is in Cerner-created I2B2, with one exception. We consider patients who do not have any non-demographic observation to be quote-unquote orphans, and we don't load them here. So if they only have, let's say, date of birth, gender, race, but not a single diagnosis, not a single med, not a single lab, you will not find them here. So if you scroll this panel down, or if you have a screen big enough, maybe it's going to be already on your screen. At the bottom here, there are text input fields to be able to put in a threshold or an interval for a value of this test that you're looking for. So you're unlikely to be looking just for patients who've been tested for A1C. You want something like, I want patients who have A1C greater than or equal to 7%. Actually, that's interesting. This may not be the right test. It's typically expressed in percent. But we'll go with it for now. So as you put in numbers into those input fields, you see that the graph changes. We gray out the portion of the graph that will be ignored, sort of. It tells you that we're going to find patients with the results that are shaded in blue. You also have an ability to specify whether you want the system to look at the most recent lab result for this patient. Because if they have more than one measurement, it's all going to be included in the data set. Or you can say ever. And typically, it would default it to most recent, but you can always override. And safe criteria will add it to the list. You see hemoglobin A1C is added, and the qualification, this threshold that we set of over 7 is listed here. You can always click on it to get back if you want to change it. All right, we've done enough work for the machine. Let's have it do some work for us. We're going to click this big button that's just begging to be clicked, count patients, and let's see what we find. So after it runs, notice it runs pretty fast. Again, the appliance has like half a terabyte or terabyte, depending on the size of the institution, of memory, and the entire database pretty much lives in memory, so it will do these calculations very quickly. So this is the most basic operation of the tool. You basically enumerate the things you want your group of patients to have by hunting and picking and finding things you want. You click this button and you find out how many. It does a lot more. We'll go into the details. You've already seen Liz show some of this, but I want to make sure we have this basic stuff sort of down. Before we move on, I want to point out a couple more things. We put in things that are diagnosis, meds, labs. We haven't done anything with demographics. So here, to the right of the network drop-down, you have this little field that talks about the population. So right now, our query includes any age, any sex. We haven't specified anything. We haven't restricted the population in any way. If you click on this little pencil icon, you will get a drop-down that has the age distribution of the entire population again. So this is what the entire patient population looks like from the age perspective. Notice that to be HIPAA compliant, we cut off everybody who is over 90 to be compliant with the limited data set of the identified data set. You will see this very specific features of baby boomer generation. If you're into census and demographics, you will know what they signify, but it's a pretty good looking distribution of ages. Long story short, you can do things like, I want to restrict my query to patients, let's say between 18 and 65. You can use the tab key to move between the fields. Again, just like with labs, when you do this, we shade the areas of the graph that will be included versus excluded to give you a visual idea of how the tool will behave. You can say that you only want men, or you only want women, or both. And once you're done, you can save the criteria. What you will see is, in this field that talks about the population, the number has just gone down. So instead of 770, when we took this adult population, we're now down to 472.3 thousand patients. So this gives you a visual indication of what happens to your base population when you do this. Okay? And then one more thing before we proceed. Let's look at these little end statements that connect our individual terms. So each criteria, if you think of it as a list, like as a bullet point, the default is and. So you're looking for people who have a diagnosis of diabetes and taking oral antihyperglycemics and are on insulin and have elevated A1C. It's kind of a nonsensical query. In fact, now the reason we're finding patients is because a bunch of people start with metformin, proceed to insulin, and so ever in their charts, this is indeed true. But a much better question to ask, and if you hover over your mouse over the end, you will see the little or appear. And if you click on the or, it switches ends to ors. So a much better question to ask, and it essentially creates a mini phenotype of diabetes, is I'm looking for people who either have a diagnosis, or who are on oral drugs, or who are on insulin, or whose labs indicate they have the disease. So you just created this kind of a complex mini definition of what a diabetic patient looks like. Obviously, it's not exhaustive. There is a ton of other drugs and diagnoses that you can include in this, but just to give you a preview of how this might work. This could be arbitrarily complicated, so you can have OR groups connected with AND groups and so on. To give you an idea, let's add one more. Let's add hypertension. If you type HTN, we added this abbreviation as synonym, so you don't have to memorize that ICD-10 refers to this as essential, open parenthesis, primary, close parenthesis, blah, blah, blah. And just type HTN. And when it goes in, again, by default, it's ended. So you see an OR clause with our 4 criteria and hypertension. So now we're looking for people who are diabetic and hypertensive, but we define diabetes in a more complex fashion. And then lastly, let's say I'm going to study a drug that's metabolized by kidneys, and I want to exclude folks who have chronic kidney disease. So the stuff that I don't want patients to have goes into the right-hand column, and we'll put that here. So you can always think of it as a logical and not. So diabetes and hypertension, but not chronic kidney disease. And again, the most basic thing you can do is to count. As we expected, the number goes up because it's a much more sensible question to ask. And so here we have 12, almost 13,000 patients who conform to this criteria. So we'll leave the cohort, the query builder at this point. It does a lot more, and we'll come back. But I want to show you other analytic functions besides this counting of patients. So there's a little drop down that also kind of begs to be clicked. And the same functionality is available on the left-hand side. So there are 3 things we will go over: explore cohort, rate of arrival, and criteria analysis. And we'll start with explore cohort. So we will click explore cohort. If you do it on the left side, you will end up with a page that is blank with a run button at the top. Click that. If you do it here from a drop down, it's going to immediately go and actually perform this function. So what explore cohort does, if you think sort of logically in terms of interacting with this tool, you just define the population of patients. Your next question is how many, click count. Your next question is what do they look like from a clinical point of view? What can I learn about these patients? So explore cohort fetches additional information about patients in the cohort you identified and allows you to review it. So these are our almost 13,000 patients. This is what their age distribution looks like. So we obviously started at 18 and ended at 65, so that's why it's cut off. But you see that it's markedly different from the overall population. It's highly skewed to the side because they're older people. That's where you find hypertension and diabetes. So your mean age is 55. Standard deviation is 9. You've already seen the screen when Liz showed it. This is the distribution of males and females, race and ethnicity. So this is what their demographics look like. You can stack and group genders. You see that there are more men in this group as opposed to women. If you were looking at kids, you can look at the first 3 years of age by months. So for pediatricians, that might be very helpful, for neonatologists especially. So this is demographics. And now if you look at the navigation bar on the left side, it kind of dropped down the explore cohort and is showing you secondary pages here. So we're on demographics. Go ahead and click on diagnosis. It will show you essentially comorbidities. So for this population of patients, what other diagnoses do they carry at what frequency? The blue stuff is already in your query. We said they must have hypertension. Remember, it was something with a logical end, so indeed 100% of patients have it. Now, if you remember my comment last time I was hugging the microphone, not every diabetic carries a diagnosis of diabetes, and boy, is it true here. So only 58% of patients have a diagnosis. We know they have diabetes. I mean, they're on insulin, they have A1C elevated, but they don't all have the diagnosis. So be wary of constructing queries that only rely on diagnosis. And metabolic disorders. This is if you go and explore. This will obviously be high cholesterol, as you would expect. So as you go and look at this, it tells you more about this group of patients. Now, if for some reason you want to say, now that I'm looking at this drug that I am studying, or this new procedure I'm considering, I want to exclude people with high cholesterol. If you click on it anywhere, click on anything in the results of Explore Cohort, you get these buttons that would allow you to add that concept back to your query. So you can say add to cannot have, and if you peek back at the query builder, you will see that it's going to be added, and next time you run your analysis, folks with hypercholesterolemia are going to be excluded. So you can interact with the results, if you wish to do so, to learn more about the cohort and to actually refine your query as you're doing so. So let's see, I don't want this. Going back to Explore Cohort, it won't rerun if it's already been run. So when you use the left side navigation, it will bring you back to where you were before. So we looked at diagnosis. I'm going to eat up all the time in details. There are lots of details. If you're looking for a specific disease, you can actually type it here instead of having to open individual files and folders. So I typed in asthma. It went all the way down to the very bottom of the list, and it found somewhere here the occurrence of the word asthma, and you can go up and down. It found like 31 of them. So you can search these lists. You can, for diagnosis, you can actually filter them by acute versus chronic. So you can only ask it to show you people with acute illnesses, or only people with chronic illnesses, or all, if you wanted to do that. So you saw hypertension disappeared when I said acute, came back with diabetes when I said chronic, and so on. You can also do time slicing. So we'll take a quick second. So we have 3,400 hypertensive patients anytime. What if I want to see the same cohort of patients, but in the last 2 years? So I'm basically asking, don't look at the entire history, look at only people who had a relatively recent contact with the system. So in the past 2 years, 1,600. So you see this histogram kind of shrinks and shows you only patients with more recent data. So again, if you're looking for prospective recruitment, you're looking to get more recent data, this is one of the ways to get an idea of the recency of the cohort. Questions? You can explore on your own, but yeah.
For certain medications, they're not always taken for the primary indication that they're given. For example, a lot of breast cancer patients or women who are at high risk for breast cancer patient are now starting to take metformin. So the query that we have just done can select for women who are at high risk for breast cancer patient and have hypertension. So is there a way to filter medications for the primary diagnosis? I don't know if this is captured in a systematic way.
It is not. So typically, if you are familiar, if you built or designed an EMR, you know that for e-prescribing, in the standard for e-prescribing, there's actually a field for indication. People are desperate for that information. They really want to know why. Pretty much always goes unfilled. Now, the only thing you can do is to exclude breast cancer, right?
So, but it would not have been possible under the must-have to couple have a diagnosis of diabetes and taking metformin, or having a diagnosis of diabetes and taking metformin. Like it's sort of like
Yes.
It's not like or.
You can absolutely break it up into smaller ors connected with ends and have that be. Now the logic only goes sort of, if you think about it, one level deep.
Yeah.
So you have and at the outer edge, you can go to or. You cannot go to and one level deeper quite yet. We actually consider, so if you think about it, it's and or. You can go deeper and deeper. We haven't really seen compelling use cases with that depth of logic. But to the extent that you can deal with only 2 layers of depth, you can represent it here. There are actually other tricks. When I talk about temporal, I'll try to remember to show you how to group your criteria into events.
Yeah, I did that. So I actually, because this is where you submitted a grant 2 weeks ago, and it's going to save maybe 20 hours of work.
Okay, we're recording this, right? So another plug for my beautiful synonyms. You don't have to memorize malignant neoplasm of. Just type the colloquial phrase breast cancer and you will find it. Well, actually, since I am here, why don't we? Just for 1 second, I will show you something that you do not have, but a few institutions are beginning to provide. So, for oncology diagnosis, if you pour in data from tumor registry, what we can do is we can tie that information with EMR data. And let's say the diagnosis of breast cancer, from tumor registry we can ferret out. So, billing diagnosis doesn't go very much farther. You have no idea of this. You know the anatomic locations. So the children of C50 are anatomic location of the tumor within the breast, but it has nothing to tell you about severity of the disease, which is really what you want. So staging information, histology and behavior of the tumor, and then specific cancer-related factors, so like Gleason score for prostate cancer and so on, are easily obtained from tumor registry. And if you have that data, we can easily integrate it into the same interface. So somebody who is an oncologist and is doing breast cancer, this number, ER negative, PR negative, HER2 negative, is kind of a gold mine and is practically impossible to calculate. Here, you just saw me click a couple of buttons in a few seconds, and if I run this query, I will get the count. Now here, I am emulating a pharmaceutical company researcher. I just selected a network that has 41 sites, and so this is what pharmacies they cannot see individual institutions. They're locked into running all of their queries against an entire network, looking for individual sites. But I just wanted to show you this particular data, what it looks like.
So a tactical question, because we're very interested in
Yes.
in this. So in terms of software supports, you presumably have tools
We do.
that pull data in from registry. So we get the blessing. You can do your work.
Exactly.
Cool.
Yes, we refer to them as toolkits. They will go against the back end.
Yeah.
If you have a tumor registry by a common vendor, and if not, we can actually read the NASR report that the registry generates for public reporting, parse it and ingest it. So there are multiple ways of getting that data in. Okay, let's move on. Okay, back to Stony Brook. We will get rid of this. We're back to our query. We'll do some more analytics. So we actually haven't gone very far here in Explore Cohort. So we looked in depth at diagnosis. Procedures and meds give you the same idea. So what procedures these patients go through, again, time slicing, filter by ICD-10, by CPT, medications, what drugs they're on, again, by frequency, again, with time slicing. Again, you can search for drugs. So, everybody is, of course, on Tylenol. If that's not at the top of your list, something is wrong with the data. That's one of my data quality assessments. The next most common one is sodium chloride. I won't surprise anybody, but then interesting stuff begins. When it comes to labs, we're actually showing a slightly different view. We organize labs by common panels. There is a view to see all of them. So here at the top it says show. You can see all the labs in sorted alphabetically, but if you want to see them by panels, So your extended Chem7, your CBC, your LFTs, and by the way, the right side panel, the one that has the new query button and a bunch of other stuff, there's a button called hide. If you want more screen real estate, you can hide it. It keeps the history of queries. Every time you click a button, it will create a card, and so you can go back and see what you've done before. It's not absolutely essential. You can hide it, and that gives you a little more screen real estate. But for labs, let's say cholesterol, right? So for cholesterol, we actually tell you right here that the mean result for cholesterol in this group, in this hypertensive diabetics, is 176 plus or minus 44. This is the minimum, this is the maximum, this is how many patients. And if you click on a lab, we'll give you a distribution curve for this particular cohort. And 2 lines of summary statistics. You can see at the entire population versus this particular population. And you can do this for essentially anything you want. I wonder how glucose will behave. So glucose across the entire network, so these are healthy patients as well as diabetics, versus our group who are only diabetics. Again, the mean is higher, as you would expect. So that's another way to evaluate.
Where are the diabetics in there?
So everything we're looking at so far is our patients. These are the ones with diabetes and hypertension. The second, so if you look at the summary statistics, this little table, network stats is population overall. Query is the cohort that we have defined.
And you can overlay, how do you overlay?
And just for the person who asked about the grant submission, I'm thinking that perhaps the screenshot piece might be useful in something like that, or with each other.
Yes, indeed. So if you like the pretty picture, you can click on the camera icon, and chances are it will work. It will save an image on your right. Somebody click on it. Don't prove me wrong. It will save a picture. It's not working? Okay, I'll take it back. I'll take it back to our technical team.
When it goes to the network status, is that including any cuts you made for demographics, or is that the entire subset that has this particular panel?
You're asking about this.
Right, so if you made a previous cut to demographics, at this point, is it going to include that demographic cut, or is this just all?
Entire population.
And can you overlay them? Can you look at the distribution of the network?
There actually is a way, and I don't know if you have it or if it's just me, but if you open the side panel, there's a button called Compare Cohorts. It is something we are currently cooking up. It may not be available to you yet, but there's going to be a way to actually, so these cards, as you go through and create queries, you will be able to select 2 of them, click Compare Cohorts, and it will put all of the output of Explore Cohort, the list of diagnoses, the labs, side by side, and like color 1 blue and color 1 green, and you'll be able to see overlaps. It's not quite there yet. I'm going to hold off on demoing it, but we're definitely going in that direction. All right, so let's look at another piece of analytics. So if we're back at the query builder, and you do this drop down, you can click on rate of arrival, or right here on the left side, you can click on rate of arrival. Same thing. Go ahead and click on it. So just to take us back into what we've done, we can count the patients, we can learn clinical information about them. The next logical question, especially if you want to recruit them prospectively, is how many patients like the ones I just described will come to this institution like next year? And so what we do behind the scenes is we take that query definition, we walk it back quarterly in time to establish a 3-year baseline. And here on this little sparkle line, it's shown in solid blue line. And then we project forward based on the shape of that line. So we can tell you that you will see 107 patients show up who look like, actually, this was run based on a different version of the query. But hopefully you haven't changed yours. It doesn't really matter. The idea stays the same. You're expected to see, we'll project a certain number of patients, like the ones you described, who will show up here in the next year. So it gives you an idea of the volume. So if you know you need to recruit 30 patients and 20% of them will accept when you approach them to participate in your trial, it gives you the basis for those kinds of calculations. Okay. And then the last analytic I want to show. Actually, it's good that I have my query screwed up like this. It will make the picture appear better. I'll add one more. Is analyze criteria. So this thing that looks like a little funnel. So this one is targeted more at folks who are designing the eligibility criteria for a trial, feasibility work. When you click on it, you will get little wizard that will walk you through 2 steps. Step 1, identify something in your eligibility criteria that is non-negotiable. You must have that. So let's say they must be on metformin. I cannot negotiate. This is a must-have. You can leave it, or you can leave it without any selections. You click next, and then you can select individual criteria for analysis, or you can click the select all to get them all. I think we'll limit you to 15, so if you design a very complicated trial, only 15 can be selected. The reason being is we have to run n to the power of the number of criteria you select here, a calculation to run this analysis. Start analysis, zoom, and it builds a funnel that will basically inform you of how individual criteria affect the size of the population. So overall population size is this. When you figure in your must-have, your non-negotiable criterion, which was in our case metformin, you're down to this size, and it goes down from here. It's organized by either most to least or least to most. The percentages here tell you the change from the previous line. So by the time you add hemoglobin A1C, you drop 26% from the previous line where we restricted it by hypertension, for example. And then the beautiful part about this analysis is you can say, hypertension is really making me lose a lot of patients. If you hover over this little blue arrow and click hide, it removes hypertension to the bottom of the list, takes it out of the funnel, changes all the numbers, and tells you your cohort will grow by 31%. So we've already pre-calculated all the permutations of this criteria, and you can play by taking them in and out and seeing what happens to your cohort. So insulin doesn't seem to make much of a difference. Diabetes really doesn't seem to make much of a difference, but hemoglobin A1C does, and maybe here I need to think about my threshold. What happens if I go up or down? So this kind of analysis will help you get a really good handle on the effect of individual criteria on the population. Again, little camera icons.
You could have a pop-up blocker, that's why.
Something. They broke it. We broke it. It will say once we fix it. It'll save an image to your downloads folder. You can put it in your slide presentation. So, okay. Enough of this. Let's spend a little bit of time on temporal, unless there are any pressing questions. Yes, please.
So what you've demonstrated is very interesting, actually, what I'm working on. However, I have some concerns about your data quality assessment. So in one of the queries, you use the A1C, and then when you drop down, you only see one normal code. However, in the
Yes.
So that data quality is very important when people use this system. So that's my concern.
So let me show you what we do along these lines. So I search for glucose. Here's a bunch of, and see, one is M. This is actually glucose you take as a medication. You can narrow it down to labs if you click on labs. And here's a bunch of glucoses. You will notice that some of them carry lowing codes. You will recognize them by having a dash and a checksum digit at the end. But some of them will have a TriNetX arbitrary code. If you choose, and these are typically the ones that we consider our top 100. If you choose one of those, there is a button there that will say Show Included Lowing Codes. So for this particular glucose, this is glucose in blood. Look at the list of, so we essentially made a call to say that these lowing codes are equivalent from a clinical point of view. A lab pathologist will probably quibble with me, and we can definitely have a conversation, but this is what we've decided to do thus far. If you look at these descriptions, you'll understand why we rolled them up. So, one I want to really call your attention to is this one, glucose in serum or plasma, glucose in blood, and then the kicker, glucose in serum, plasma, or blood. So, if you have one of those, then it's kind of a sin not to roll up the other two, because obviously the way it's going to be used in the real world is people are going to mix this. So you will see that we call them top 100. It's probably somewhere in the neighborhood of 75 most commonly used labs. You will see them appear with these TriNetX codes. Everywhere where we do some kind of monkeying around with standards, like rolling up codes or mapping. Let's say for diagnosis, there's a little show ICD-9, and if you want to see exactly what I did with ICD-9 of 401, well, I mapped it to ICD-10 of I-10. We always try to disclose it somewhere in the interface, so you will see the things that we've done. And so when it comes to labs, we try to roll them up to make sure that you don't have to hunt and peck for a half a dozen individual glucoses trying to find it. Now, the A1C, you were absolutely right, because the one I chose for this demo is not the right one. This one is mass per volume. This is concentration of hemoglobin A1C. And the one I really wanted was the ratio of glycosylated hemoglobin to normal hemoglobin. I don't see it here, which means that it's not in your I2B2 for one reason or another, and we have to look to see the lowing code you quoted is exactly the one I was expected to find. We need to find the reason why it's not here. You don't have it in your data today.
So from our data, definitely we have that code comment in our raw data. So I'm very familiar with our data, and that's why it's very strange that the normal code didn't show up until our data kind of not common. So that's I was worried. How did you get this data so far? That the integration with data.
I would assume that your I2B2 is already coded to lowing when it comes from Cerner, so we didn't do any lab mapping here. But I will double check. I will double check our records.